This is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering. Today, I would like to deal the course Unconventional Machining Process. Under this, the topic is Introduction to Traditional and Non-Traditional Machining. At the end of this session, student will be able to classify the traditional and non-traditional machining process. Second one, compare the traditional and non-traditional machining processes. Right. Basically, in manufacturing, the machining will play a predominant role. Out of all other processes, the machining process will be a predominant process. So here, the material removal will be the main criteria. So in different machining processes, the material removal will be in different ways. Right. See, this is what material removal process. So under this, as we discussed, the main content, that is the difference or the comparison between traditional and non-traditional machining. Okay, now let us have a look on traditional machining. So in traditional machining, again, the material removal will be in two broad categories, that is cutting, number one, and mechanical abrasion. Later we will see the non-traditional or unconventional machining process. So before we going to discuss the non-traditional machining process, we have to come to know what is the conventional machining process or traditional machining process, what we have learned so far. Let us brief the cutting and mechanical abrasion one by one. Now let us see. Come to cutting. For circular shapes, we have three different operations like turning, boring, drilling. Okay. So under cutting, for circular shaped products or parts, whatever it may be, or components, we have to use the turning operation, boring operation, and drilling operation. Again, in turning, there are different varieties are there. Step turning, taper turning, we'll see. Okay, so here turning will be done by a lathe machine. Okay, we have know what about lathe machine and the different operations performed on lathe machines. We'll see all these traditional machineries in detail later if at all required. Okay, right. Now, what is boring and what is drilling? Drilling means making a hole with the action of some cutting. Okay. So here the workpiece will be fixed and the cutting tool enforces to remove the material. Okay. Right. What about turning? In turning, the tool will move and at the same time the cylindrical or circular shaped workpiece will rotate about its own axis so that the material will be removed. Okay, that is the main difference between turning and boring. So in turning, the workpiece will revolve about its own axis, and in drilling or boring, the workpiece material will be fixed and the tool will rotate and enforce into the workpiece for the material removal. Okay, right. Now let us come to the other processes to get various shapes other than circular shape. Right. Milling, planing, shaping, broaching, sawing, filing, gear forming, gear generating. Right. Now let us see in brief what is milling. Again, what is the plane milling and surface milling? We will see all these in detail if at all required. But basically, when we deal non-traditional machining process, the information of traditional machining process will be useful as the basis. So that's why we have to deal in brief the traditional machining process. Okay, so the significance of learning this traditional machining process is very much required to enable or to move on non-traditional machining process. Right. What is milling? So here in milling, the material will be removed when the workpiece is fixed to the table or vise, and the table will move or the tool will move. Okay, so in just simple milling or planing, the tool will be moved. In shaping, the vise will be moved so that the entire workpiece will be moved. So these are the other various shapes formed by different cutting processes. So here these two, circular shapes and various shapes, are under the action of cutting. Okay, now let us see in detail. The mechanical abrasion comes under traditional process, MA, mechanical abrasion. Right. In this there are mainly two categories. One is bonded abrasives, second one is loose abrasives. Okay, one is bonded abrasives, second one is loose abrasives. Right. Under bonded abrasives, grinding, honing, coated abrasives. Okay, so under this the material removal rate will be higher, but with some coarse removal form. Right. Under loose abrasives, polishing and buffing. So these two are for finishing. That means in order to get surface finish like glass, we have to use polishing and buffing. Here the material removal rate will be very less, but fine structure that we will get. So here in bonded abrasives we will get coarse finish. Under this loose abrasives we will get fine finishing. Okay, but here the material removal rate will be little higher. In this the material removal rate will be lower. Okay, but here the surface finish will be higher, here the surface finish will be lower. Okay, so that is the main difference between this bonded abrasives and loose abrasives. Right. Now let us see the non-traditional processes. Okay. First one is CHM, chemical milling, ECM, electrochemical milling, ECG, electrochemical grinding, EDM, electro discharge machining, LBM, laser beam machining, AJM, abrasive jet machining, WJM, water jet machining, PBM, plasma beam machining, USM, ultrasonic machining. Okay, so I wanted to iterate one more time. Okay, CHM, chemical machining, ECM, electrochemical machining, ECG, electrochemical grinding, EDM, electro discharge machining, LBM, laser beam machining, AJM, abrasive jet machining, WJM, water jet machining, PBM, plasma beam machining, USM, ultrasonic machining. So these are the some of the non-traditional machining process. Okay, right. Under non-traditional machining processes, again the material removal process will be in three different ways. First one is mechanical, second one is thermal, third one is chemical or and chemical electrochemical. Okay, chemical and electrochemical. Okay, so again under that there are some other methods are there. Now let us see the mechanical non-traditional machining process. The first one is ultrasonic machining, water jet machining, abrasive water jet machining, ice jet machining. Okay, now let me write USM, ultrasonic machining. Second one is water jet machining. Third one, abrasive water jet machining. Last one is ice jet machining. Okay, so first one ultrasonic machining, second one water jet machining, third one abrasive water jet machining, fourth one ice jet machining. We will see all these in detail with complete information with semantic diagram in the coming presentation. Okay, now let us see the peripheral information of these mechanical, thermal and chemical and electrochemical non-traditional machining process. So out of these mechanical non-traditional machining processes are based on the forces, mechanical forces. Okay, these are ultrasonic machining, water jet machining, abrasive water jet machining, ice jet machining. Now let us come to thermal non-traditional machining process. So because of the thermal effect, the material removal will be taking place. Okay. So in first one, because of mechanical forces, the material removal will be taken place. In thermal, because of the thermal effect, the material removal will be taken place. So under this, electro discharge machining, let me write electro discharge machining, EBM, electron beam machining. Okay. Third one, LBM, laser beam machining. Okay. Next, IBM, ion beam machining. PBM, plasma beam machining. So here in thermal non-traditional machining process, based on the requirement, we have to choose the process, though we have different thermal non-traditional processes. Okay, right. So here EDM refers to electro discharge machining. We will see in the coming slide what is electro discharge machining and what is EBM and all this. Okay. Second one, electron beam machining. Third one, laser beam machining. Fourth one, ion beam machining. Fifth one, plasma beam machining. Right. Now we will see chemical and electrochemical machining. First one is chemical machining, CHM. Chemical machining. Next, second one, PCM, plasma chemical machining. Third one, ECM, electro chemical machining. Okay, now we will see all this in detail. So before we going to next slide, let us summarize the three different approaches like mechanical, thermal, chemical and electrochemical. Mechanical non-traditional machining process will be due to the mechanical forces, that means striking something against the workpiece so that the material removal will be taking place. So here mechanical forces will act on the workpiece to remove the material. Second one, thermal. So here thermal effect will be the reason due to, here the thermal effect will lead to remove the material. Okay, so this is very predominant sometimes, okay, where we cannot use this mechanical non-traditional machining process. We have to choose thermal non-traditional machining process. Right. Next, third one, chemical and electrochemical machining process. So here the action of chemical and electrochemical reactions, the material removal will be taken place. But here the material removal will be very less, but where the accuracy is required, where the intricate shapes are required, we have to go with chemical and electrochemical process. Okay, this is third one. Right. Now we'll see the same in the coming slides. Right. Mechanical non-traditional processes. Okay. Under this, ultrasonic machining, water jet machining. Okay. So here, ultrasonic machining process will be performed because of this abrasion. Okay. And water jet machining process, the material removal will be taken place because of the cutting action. Okay. So here abrasion means the abrasives will be the act as like a tool here. Okay, abrasive, that means the part of it in the cutting action. Here the jet will take care of the same cutting. Here the slurry will flow against workpiece. The slurry contains the very sharp edged materials, okay, small size, and with the combination of water, so that it strikes the workpiece and the material removal will be taken place. Okay, in water jet machining, we are not using any slurry. Okay, a kind of fluid that we will use, and this water jet strikes so that the workpiece will be eroded. That means the cutting action will take place and the material removal will be taken place. Okay, so here the main medium is abrasives. Here the jet of water. Okay, so here the flowing medium on the workpiece is here slurry, here the fluid. We will see all these in detail. Okay, right. Next, thermal non-traditional machining process. So electro discharge machining, electron beam machining, laser beam machining, plasma beam machining, ion beam machining. So here this is somewhat self-explanatory. The same terminology will come as the medium or the main striking tool. Okay, so here because of the discharging of electrons, the cutting action will be done. Okay, so here the medium is dielectric medium. Okay, and here the plasma will be the tool-like thing. Okay, so here the workpiece will have to undergo material removal, and that dielectric medium will flow. Okay, again plasma will strike because of this discharge of electrons. Okay, next, second one, electron beam machining. So here beam of electrons will strike, so that here the electrons are the medium, striking material, and medium is vacuum. Here we are not using any dielectric medium like electron beam machining. Okay, electro discharge machining. In electro discharge machining we are using a dielectric fluid as the medium, but here the medium is vacuum, no medium. Okay, so electrons will strike the workpiece in the vacuum. Okay, so before we start material removal, the workpiece should be perfectly clean and we have to maintain vacuum. Okay, so we have to keep the workpiece in the vacuum chamber. That means the setup of electron beam will be like that. Okay, so directly the electrons will strike the workpiece and subsequently the material will be removed. Okay, next, third one, laser beam machining. So it is because of the action of laser beam. Okay, so here the photons are the striking material like cutting tool, whereas in conventional machining process, and here the medium is air. Okay, so here the workpiece will be perfectly cleaned and the medium should be air. Perfect air we have to maintain. So the photons will strike the workpiece through air so that the material removal will be done. Next, plasma beam machining. So here a kind of gas, okay, that means nitrogen or sometimes combination of nitrogen and oxygen that we can use as the medium, and here the tool action will be by plasma. Okay, so here the plasma will strike the workpiece through gas so that the material removal will be taken place. Next, last one, ion beam machining. So here ions are the striking materials. Similar to electron beam machining, the medium is vacuum. So here and here the medium is vacuum. Okay, so that material removal will be taken place. Okay, so I wanted to summarize the thermal non-traditional machining process. There are 5 thermal non-traditional machining process: EDM, electro discharge machining; EBM, electron beam machining; LBM, laser beam machining; PBM, plasma beam machining; and IBM, ion beam machining. So here in EDM, the material removal will be taken place because of the action of discharge of electrons and the plasma, that is plasma, and the medium is dielectric fluid. Okay, in EBM, the electron beam, that is electrons, the medium is vacuum. In laser beam machining, the striking material is laser beam, that is photons, and the medium is air. In plasma beam machining, plasma beam, that is plasma, and the medium is gas. In ion beam machining, the ion beam strikes. Okay, here the ions are the striking materials, and vacuum is the medium. So for EBM and IBM, the medium is vacuum, right? Next, chemical and electrochemical machining process. ECM, electrochemical machining. CHM and PCM, chemical machining and plasma chemical machining. We'll see one by one. So in ECM, the striking material is ions. Okay, so in chemical or plasma chemical machining are ions. Okay, so here in electrochemical machining, electrochemical discharge would be the striking one. Here chemical discharge will be the striking one. Okay, right. Here the medium is electrolyte. In electrochemical machining, the medium is electrolyte. Okay, so in chemical machining or plasma chemical machining, the medium is etchant. Okay, so that the material removal will be taken place because of this electrolyte and etchant in these electrochemical machining and chemical machining and plasma chemical machining. So we'll come to know all these in detail with complete diagrams and simulations in the subsequent slides or presentations. Now, what is traditional machining process at the end? Okay, first we have started with some traditional machining process. Now at the end we are going to compare the traditional and non-traditional machining processes. Okay. Now let us see the traditional machining process. Traditional methods of machining involve operations such as drilling, boring, cutting, milling, etc. with the help of traditional tools having a cutting edge. Okay, so we know what is single point cutting tool for lathe operations, what is multi-point cutting tool for drilling operations or milling operations, that we have come across all these cutting tools and the different operations performed on different machine tools like lathe machine, milling machine, drilling machine, boring machine. Okay, but here because of the direct mechanical contact and mechanical forces, the material removal will be taken place in the traditional machining process. So here the tool directly strikes the workpiece. Either the workpiece may be moving or revolving one, or the tool may be sometimes moving or revolving or some in linear motion. Okay, so based on the requirement we have to use different machinery and cutting tools. Okay, for circular shapes we have to go with lathe machine. For prismatic workpieces we have to go with milling machines, that we have know already, right? With the increase in the technology and evolution of time, these conventional methods of machining became outdated, though these methods are the basis of the machining process. So we cannot say all these traditional machining processes are useless, but based on the requirement we have to choose. But only with this traditional process we cannot manufacture or machine on different materials for different or specific purposes, right? So we have to go with some non-traditional machining process. Basically for intricate shapes we cannot use traditional machining process. For regular shape parts or components we can make use of this traditional machining process, but for intricate and specially designed parts or components we have to go with non-traditional machining process. Now let us see what is non-traditional machining process. When a component is manufactured with the help of modern technology and without the use of traditional methods, then the machining process is known as the non-traditional machining process. The non-traditional machining process is also known as non-conventional machining and modern machining process or unconventional machining process. So basically, we cannot use non-traditional machining process just to make a hole on some flat workpiece for the general purpose. The purpose is very much important. Then only we have to go with non-traditional machining process. Otherwise, it will be very much expensive. We'll see all these things in subsequent presentations. So we have to use traditional machining process and non-traditional machining process. So between these two, there are some other sophisticated tools. That is the development of traditional machining process. For example, for lathe machine, we have CNC lathe machine. For milling machines, we have CNC milling machines. CNC means computer numerical control machines. And even robotic technology also adopted to control all these traditional machining process. That was the development, but it is not the next development of that process is the non-traditional machining process. This is completely different. Okay, so here, because of the action of some mechanical or thermal or chemical action only, here the material removal will be taken place, whereas in traditional machining process the material removal rate will be very higher because of the complete direct contact of tool to the workpiece. So this is what the comparison between traditional and non-traditional machining process. So in the coming presentation, we'll come to know each non-traditional machining process in detail. Right. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.